Hello everyone, and welcome to a video where I'm going to explain how to factor quadratic trinomials where there is a leading coefficient other than 1. So you have a number in front of your x squared. Now there are lots of ways to do this, but this is my favorite way. So what we do, just like before, we have a sum of this number, but we need a product number. So I'm going to do 4 times 15, and 4 times 15 is 60, and that is my product. So I need two numbers that multiply to 60 and add to 16. So now I'll find factors of 60. Now, if you watched my other video, you watched me do this factor tree, and I told you could pair up the numbers in different ways so that you could find all the factors. So if I took all of these numbers, multiply them together, I would get 60. So 60 times 1 is one of my pairs. And then I could just do 2 as one of my numbers, and 3 times 2 times 5 is 30. So I could get 30 times 2. And I could do 3 times 4 times 5, or 3 times 20. Okay, and I could do 5 times 12, and I could do, let's see, this is 4 times 15, and I think that's all of them. Oh, I forgot 6 times 10, the best one. Okay, so we have all of these numbers now. Now notice this product is positive, meaning they have the same sign. The sum is positive, meaning that that sign is positive. So I just need to find a pair that adds up to 16, and that's going to be 6 times 10. Okay, 6 plus 10 is 16. 6 times 10 is 60. Now here's the tricky part. What I do in this factoring method is I keep the 4x. Ignore the squared. The 4x goes in both sets of parentheses. Okay, and then 6 and 10 will go in these other spots. And now we know that this is wrong, because if I was going to multiply this, 4x times 4x is 16x squared, not what I have here. So what we're going to do is we're going to divide each set by its GCF and forget that that GCF was even there. So here the GCF is 2, so I'm going to divide by 2 to get 2x plus 3. And that 2 is just going to disappear like it was never there. This GCF is also 2. So I'm going to divide that out and get 2x plus 5. And that is the factored form of that trinomial. Okay, let's do another one. Here I have 5 times 8 for my product. And my sum is going to be this negative 14. Okay, so multiples, things that are factors of 40 is 1 times 40, 2 times 20, and 4 times 10, and 5 times 8. Now notice my product is positive, meaning they have the same sign. My sum is negative, meaning that that sign is negative. So I made all of them negative, and now I look for a pair that adds up to negative 14, and that would be this one, negative 4 and negative 10. So again, I'm going to copy the 5x, not the squared. So 5x in both sets of parentheses, and now I'll put in my negative 4 and my negative 10. And then each set gets divided by its GCF. Here the GCF is 1, so it's not going to make a change. You have 5x minus 4 here. And here the GCF is 5, so I'm going to divide by 5. So you have x minus 2. And this is the answer. Okay, one more. 4 times negative 2 is my product, so that's negative 8. And my sum is 7. So I need things that multiply to 8. So that's 2 times 4, 1 times 8. And that's about it. And notice my product is negative, meaning they have different signs. My sum is positive, meaning the bigger one has the positive sign, and the smaller one is negative. So if I add these, negative 1 plus 8 is that positive 7 I needed. And I'm going to keep my 4y in both of these. And I'll put my negative 1 and my positive 8. Now, dividing by the GCF. This GCF is 1, so nothing's going to change. This GCF is 4, so I get y plus 2 here. Okay? So that's it. That's how you factor these quadratic trinomials. There are other ways to do it. This is my favorite way. And if you need help with anything, just make sure you reach out.